we want to look at normal curves or distributions. We are starting a section for continuous variables. Now, we've already talked about distributions for discrete variables. Remember that continuous variables are those that can be anything in between. These are a lot of times measurements, and you can have like your height. It can be 5 foot, it can be 6 foot, or it can be anything in between. You don't have to be one exact value. You can be 5 foot 3/1/8 inches. Okay? And so that's why it's considered continuous. Not that it changes necessarily, but the measurement or the possible values can be anything in between. Our discrete variables can change over time, but they have to be one value or another, even when they change. But we're going to look at these continuous variables, and so we look at what are considered curves. And so the curve used to describe the distribution of a continuous variable or a continuous random variable is called the probability distribution curve. And so we're still going to be talking about probabilities. When we do this, we have to remember a few things. Probabilities tell us what proportion of the population falls within any given interval. So proportion, we're looking at out of 100. Probabilities are out of the whole. The area underneath the curve, underneath the entire curve, is going to be equal to 1. That's because, remember, all of our probabilities must add to 1. We also have to remember that probabilities must be positive, and so forth. Now here's a couple of examples of probability distribution curves. You'll notice that we have a peak over here and it kind of flows down, and this is an area between two values, and this is this area between two values. Okay, we could have looked at the area here between those two values, but you'll also notice that we come out over here. Looking at this probability distribution curve, you'll notice that this shaded area here is 0.35. And this shaded area is 0.25. So how can we find the proportion or probability of this shaded area? Well, think about it. The probability or proportion must add up to 1, so this is going to be 1 minus the sum of the other two. So we're going to take these other two and add those up, and when we do that, we're going to get 1 minus 0.6, and so this area in here is going to be a 0.40. And if you take this area and this area and this area and add them together, that will all equal 1. Well, that's all well and good if we're given the different areas. But like these, we don't know what these little areas are. And I can't assume what the areas are. So we're going to look at what's considered a normal distribution. With a normal distribution is going to have one mode, so one peak, and it is going to be symmetric around the mode. So that means it's going to be equal on the left and the right side. You can fold it in half. We talked about these when we were talking about histograms. Those approximately normal, approximately symmetric. The mean and the median are both equal to the mode. So basically, what we're looking at is something that looks similar to this. And here in the center, we're going to have our mean, our median, and our mode. And they're all going to be the same number, same value. They all equal each other, and they're in this center in which I can fold this half onto this half and they be equal. This extends infinitely for both to the left and right. So even though that this looks like it stops, it technically is going to continue to the left and to the right over here. And this follows the empirical rule. And we talked about the empirical rule before. That is that 68, 95, 99.7 rule. Okay? And in the next video, we will go further into detail with this.